Hello friends, welcome to M for Math, where you will love maths. This channel is completely dedicated for class 10 CBSE students. So before I start, I request everyone to please like, share and subscribe. And don't forget to share this video with all your class 10 students who find maths very difficult. So friends, today we are going to start with the chapter 1, real numbers of your NCERT textbook. Today I'm going to start not from the beginning of the chapter, but today we are going to discuss how to prove if root 2 is irrational. So before that, we have to discuss something more. We have to discuss, we have to learn, we have to revise something more, which we have learned in grade 9 and 10. We know something about backing up of numbers. Don't worry about backing up of numbers. It's actually very easy. So first of all, what we have is a small box. In that, what we are having is natural numbers. What is natural numbers? The numbers from 1 to the infinity. All the positive integers are natural numbers. Then we have something more outside the bag. And that is another box. And that's what you call the whole numbers. Whole numbers are the numbers from 0 to all the positive integers. That is 1, 2, 3, 4, 5, 6, etc. etc. Then we have another box. Sorry about that. We have another box. And that box is our third box. And what is that box? It is our integers. And what are integers? The numbers from the negative sign that goes on and 0 is there. Then all our natural numbers, that is 1, 2, 3, etc. that are called integers. Then we have another box. Why are so many boxes in maths? That is because these all are numbers. Anyway, we are coming to the fourth box, and that is our rational numbers. What are rational numbers? Remember grade 9, any number which is of the form P by Q are called rational numbers. Now we have something else. Aside of this, we have a two small box. In that, we have irrational numbers. And what are they? Which is not of the form P by Q, then they are called irrational numbers. There comes your root 3, root 4, root 3, root 2. All are irrational numbers. So now we have a very big box. It's very important also. And that box covers everything. What is that box? That box is what we call real numbers. That is what we call real numbers. Real numbers. So, in brief, we can say every rational and irrational numbers are real numbers. So, I hope you got clear of or you got revised of all your previous knowledge. Now, we are going to discuss something interesting in this. Now, we are going to have a proof. And what is a proof? We are going to prove root 2 is irrational. Why? You would be wondering, why do we have to prove if we already know that this root 2 is coming under irrational number back? Then why do we have to prove? The reason is because maths is full of proofs and everything has a reason. So we need to prove that. So how will we prove that? So this is actually easy peasy thing, but no need of worrying. So let's start the proof. For proving that, we need to assume. Let us assume that root 2 is rational. Now, why are we saying that it is rational? Because the proof which we are going to do is a contradictory proof, where we'll be assuming the opposite of what we are going to do. So we have done that. We have assumed that root 2 is irrational. Now what we are going to do, root 2 is rational. Now what we are going to do is, since root 2 is rational, we can express root 2 in the form p by q. See, this is only our assumption that it is rational. So we are going to again assume that it is in the form p by q, where p and q are also positive integers, and they are also comprimes, and they are also co-primes, which means they don't have a common multiple. So, and also they are not equal also. P is not equal to q. We have assumed so much. Now let's come to the main part. Now we have assumed all those things. Now let's come. Let's say root 2. We have said that root 2 is equal to p by q, which implies, now let's put this q to the LHS side. So that is q root 2 is equal to p. Now let's square it up. Let's square the LHS and RHS. Then what we get is 2q square is equal to p square. Now put this as equation 1. Why, you will be wondering, that will be coming to the next part. So we have assumed it and we have got an equation also. Now what we are going to do is, before we are going to do, look at this. 2 into q square is equal to p square, which means the number which we are getting is divisible by 2. That itself means that p square is divisible by 2. We have also learned a theorem in this chapter that any number divisible by this, any squared number is divisible by a particular number, then that original number, if for example if p square is divisible by 2, then p will also be divisible by 2. So we are getting a fact that p is divisible by 2. P is divisible by 2. Now, so we remember this up. So next what we are going to do is, since p is divisible by 2, then what we are going to do is, let p is equal to 2c, where c is any other positive integer. Now we are going to square it up again. We'll get p square is equal to 4c square. Now let's put this as equation 2. Do you remember the equation 1 which we said that p square is equal to 2q square? Yes, we remember that. So we are going to bring the both equations together. This was equation number 1. This is equation number 2. Since we have a common thing over both the sides, what we are going to get is, from 1 and 2, what we are going to get is, 1 and 2, what we are going to get is that 4c square is equal to 2q square. Now we can cut off this, and then what we are going to get is finally, that is q square is equal to 2c square. This again applies the same theorem which is there in our textbook, and that is q is also divisible by 2. Divisible by 2. Now. See, all we have got. We had said earlier that they are co-primes. Q and P are co-primes. We had said firstly, we had assumed. And if they are co-primes, they won't have a common multiple, right? But we got to know that Q and P are divisible by 2, right? We have just proved it up. So now comes the main part. Since they are co-primes, it's not possible that they will be divisible by 2. So this is contradicting. It's not correct. Our assumption is completely wrong. This is contradicting completely, and which means that root 2, we have to write in our exams, we have to write this contradicts the fact that root 2 is rational. So now what? Why we are saying this contradicts? We have to add a line over here. This part we have to add that since we have to write that since Q and P are divisible by 2, we have said that Q and P are divisible by 2. So this contradicts the fact that root 2 is rational. So what is root 2? Obviously, if it is not rational, then root 2 is irrational. Wow, that is a big discovery. And here comes the end of this proof. We have completely, finally proved that root 2 is an irrational number. Then, now comes the end of this. So next thing what we are going to do is, I hope you all understood how to prove root 2 as irrational. Let's try some further questions. If we have already know that root 2 is irrational, then we can simply prove the rest very easily. So if we are asked to prove 3 plus root 2 as irrational, what we'll do is the same of the proof which we have just proved it earlier. That is, we have to assume that 3 plus root 2 is equal to a, where a is any positive integer, which means then we'll put this 3 on the other side, then we'll get a equal to, we'll get root 2 is equal to a minus 3. Since this is the p by q form, we can say that root 2 is also rational. Since we know that LHS should be always equal to RHS. But this contradicts again. We have just proved that root 2 is irrational. So we can just say that this is also irrational. So I hope you guys understood today's class. I hope you all enjoyed. So now we are at the end of today's session. I hope you guys understand today's concept. And please don't forget to like, share, and subscribe, and share this video with all your friends. To have more future videos, please support for M for Math, where you will love maths.